any questions, feel free to interrupt. So I wanted to talk a little bit about storage control. I guess I lifted the slides from our pure integration, but it actually applies to all things that we are doing in storage in general. So one of the things that we wanted to emphasize in terms of all the things that we help you control the underlying physical infrastructure, including storage, is our ability not just to be able to meet demand by matching it to the right amount of supply, but to be able to differentiate the demand. And I think most importantly, it starts with what Charles described in terms of differentiating one application versus the other by defining a different SLA, and trickle it down from there. What we could do is also take advantage of built-in capabilities of the underlying platform, be that Pure providing different level of service or other storage providers providing different level of service, and allow applications that have higher priority, that need to meet their SLAs, to be able to consume resources from faster, infrastructure providers, such as like an all-flash array with higher priority servicing that workload, or in the case of OpenStack, we're doing this with CPU shares, where we basically allow certain applications to get more CPU shares as they run in the infrastructure, run the same shared infrastructure, but get better service to meet their SLA, whereas other applications will be able to use the resources, but only if the high priority applications don't need them. But in general, what we do in terms of storage is going underneath your virtual infrastructure, as if you, especially in the private infrastructure space, is we tap into these storage providers. We take advantage of their capabilities, but end up controlling how do we best map the demand and control both the VM's allocation to storage as well as the actual storage allocation itself. We're mapping basically data stores to the volumes that you create on your storage infrastructure, to the pool of the disks that you have, all the way down to the controllers that are actually servicing all of your I/O traffic. And we end up driving a couple of decisions, such as what is the best place for this VM to run based on the application workload that it gets, based on the amount of resources that it otherwise needs across especially a diverse storage infrastructure. So with the understanding of what the underlying storage infrastructure, we actually find a better place for each of your applications, each of your VM, to meet its storage demand. And we ending up moving it to somewhere where it's able to get more IOPS, for example, or more space. But as we look at the underlying storage infrastructure, now we could do things like expand the volume, like expand the NFS share on a volume automatically, or tap into orchestration to expand other ways of provisioning storage on your infrastructure as we see a growing demand for resources. That's another example. Either create another volume, or I think my other example is to actually grow an existing volume. So since we are now tapping into the underlying storage infrastructure, we apply the same control capabilities, the same automation capabilities. You can still automate this, do this manually, go through change control. So all the same things that we described earlier on how you actually take the actions that our software identified applies. But now we are controlling the underlying storage infrastructure in the context of what we see from the application and the container and the VM demand.
Why wouldn't I just let storage DRS do the migration of stuff around? What makes you? Why would I? Yeah, I guess if I have to pick one. And if I'm running your software, I would probably pick one of this. Why would I pick VMTurbo's migration around versus letting storage DRS and data store clusters just handle the I/O?
So there's a couple of important points. One is that I think that really the story is all about providing an application quality of service, and to be able to control the whole stack with the understanding of what the application needs and how different applications need different resources, or they have relatively different priorities. I think that trying to solve this problem only at a single layer is not as well going to assure the performance of the applications. But the equally important point is that what we really want to achieve is to prevent problems in the infrastructure. We want to take these actions both in terms of migrating a VM and managing the underlying supply of resources, such as creating another volume or growing a volume, to prevent problems in the environment. I believe that storage DRS was primarily designed to react to high latency, for example. Now, if you have high latency, you're probably already not meeting your level of service. So what we want to do is to drive these resource allocation decisions all the way down from the application, and in a way that prevents those problems from happening. So you can actually have storage DRS enabled, and it's probably a similar story of our customers also having DRS enabled in their infrastructure. If you're using VMTurbo to control the environment, those bits have nothing to do, or not much to do after all, because we are actually managed to prevent those problems that would have otherwise triggered them to do something. And thirdly, it's more than about moving VMs, right? I mean, moving VMs is one bit, but
more about moving applications, right? You know.
Yeah, exactly.
So you keep using VMs, but would you move it whole? You talk about the pod or whatever. Would you move the whole thing around, or would you just move components within?
It is the whole components, right? So it's the whole. It's great that you're tying together our network controllers. That's exactly the story that we want to tell. If you are enabled, our network control module will find the best place for each VM to run within a pod, and if the whole D pod is at the risk of running out of resources, we will move the whole group of applications to another pod.
But you're thinking about it at the VM level, rather. You know, you're not thinking about it at the application level, except that one of the components serving that application is at risk, right?
What do you mean?
I guess I'm just trying to figure out how you're thinking about this. You know, when you're moving stuff around, you keep saying VMs moving around, but you know. If I've got a pod defined, if I've got an application defined, I would think that I'd want to move either the whole app or something like that, you know, like. It
would depend on, so like a VApp is kind of a common abstraction that we think of as like a multi-tier, and I hate to use the word VApp because it ties us to one thing, right? But we know what a virtual application sets in an end-tier application, and while moving those together may seem to make sense as far as co-locating them in a lot of different ways, that's the storage decision as well as the compute decision, all those other variables. It may make sense to separate them. It may still meet the application demands as far as east-west
all
latency.
The computation is really at the VM level.
And that's, VMs are a way that we talk about it.
So let me try. So if you look at our current supply chain, our supply chain representation, you actually have multiple parallel buying relationships in this. So we've got the VMs that are buying resources from your compute and your storage directly, and in that context, each VM individually makes its own decision on what is the best place for it to run. But at the same time, this vPod captures those group of VMs that make up that vPod based on their communication matrix, and they buy resources from a dpod, and a dpod is a collection of compute and storage that are closely connected. So when the vPod makes a decision on which dpod to run, the action that it drives is moving the whole group of VMs. Okay. So we are both driving decisions at the vPod level across which dpod they should be running, basically which rack they should be sitting in. Independently, the VMs are making their best decisions to find the best place within those dpods to run. Consider that because of the applications talking to each other, if a VM wants to move across two racks, that are part of the same vPod, they would have to pay more price for their flow traffic. So most of these VMs within the vPod will naturally stay within the vPod. But if that depot doesn't have the resources, then the vPod is going to move the whole bunch of them over.
So, put simply, if the VMs should move together, they will. What's the definition of should? There's some sort of affinity between those VMs.
Okay.
Now, that affinity, intangible affinity, like they're part of the same application, is not a good reason to introduce a constraint into your environment. An affinity that matters is that if you separate these, their performance will degrade, which in a lot of cases, as Endra's been explaining, is based on network traffic.
Yeah.
A lot of your affinity rules come from the fact that these things, the traffic flow between them, are sensitive to latency. So instead of defining rules, we detect that affinity in the infrastructure,
okay,
and then we make sure that it's always honored.
And then do the economics of this follow from the vPod itself? Then I can say the vPod, I don't want to spend more than X on the whole app or whatever, and then it optimizes that within.
Yeah.
Okay, cool.
So the cool thing about this is that because of how we define the SLA and how the SLA defines the amount of money that you insert into your whole supply chain, that money trickles down. So if you've got a bunch of applications that are low priority or they don't have an SLA, then by trickling down this money, the vPod that makes those things up will have less money and less buying power, as opposed to another vPod.
Yeah, and I like that because, a project has X amount of budget sort of thing, like that would be, I don't want to micromanage that at a VM level. I just like to say the whole thing gets X amount of budget, that sort of thing. So,
and that's actually a super important point, because to Eric's funny slide at the beginning, trying to determine from a guy who asked for an 8 CPU 64 gig VM on what level of service he wanted is an almost impossible reverse engineering exercise. So what we really want to change that conversation into is to have the application developer talk about the level of service they want from an application perspective, from a transaction response time perspective, and let the control system deal with the resource allocation.
And what they're willing to pay for. Yeah.
Yes.
Yeah, because I'm becoming my data center is becoming a business. I've got costs. I need to bring in customers, essentially, even if it's within my own organization. Yeah, what are you willing to pay for? Are you willing to pay for an 8 CPU, 64 gig of RAM VM? Fine, but usually, the point being, they're usually not willing to pay for that.
And I think that it's difficult for them to say that, do you want to pay for an 8 CPU VM? Because I don't think, me as a developer, I don't really know if my application is going to need 8 CPUs or 16 or 4 of them. I know that I want my transaction performance to be, and I can say that I'm willing to pay for 2,000 transactions at a sub-millisecond level. Figure out what I need to accomplish this.
We'll happily charge as a service provider, you're like, oh, absolutely, there's that thought of, you do want to just let them buy it because you're physically getting money for it, right? And that's where sometimes the conversation gets a little confused.
And I don't mind the overcommit, right, when they're not using it, but because it's money in my pocket. Yep. But realistically, if they should be smaller or whatever, I'd like to tie it more closely to their actual performance needs, should they be able to actually articulate that to me.
Yep. You also mentioned that you can move workloads from, for instance, in storage from one controller to another controller. Would you be doing anything on the hardware for that, or you're just monitoring the hardware and making the changes at the virtualization layer? You might move a workload to a different data store, or would you actually be able to spin up a LUN on an array?
So we are moving volumes. We are extending RAID groups in the cases where that problem is left up to you. And we are driving and automating those decisions. I see a growing number of storage vendors that are trying with very, very good reason to solve that problem built into the hardware. So it's not your problem. You got basically one big pool of all of your flash drives, and you don't have to worry about like RAID 16 this and RAID DP that and blah, blah, blah. But in the cases where the platform is not smart, we'll end up controlling those layers. In the cases where the platform is smart enough, we build on top of that and manage the workload demand.
So do you have a list of vendors that you will work with, like storage vendors that you'll work with?
Absolutely. So we currently support EMC, VX, NetApp, 3PAR, Pure, and we're working on a couple of others that we'll announce in next month. Sorry.
One more question. You said earlier on a question there that the DRS, for example, wouldn't have anything to do because VMTurbo does this. But there are other resource schedulers. For example, if I run a virtualized scale-out file system that takes decisions as well, how would you advise to not run that and leave it all to VMTurbo, not use the native resource scheduling, or?
No, I think that what we really are after is to solve the application performance problem, and there are a bunch of things that the infrastructure providers are solving, such as Microsoft Scale-out File System. I don't want to interfere or to mess with their ability to provide a clustered file service. We actually are announcing our support for SMB-v3, and we are dealing with SMB-3 as a black box, basically. Okay. We let them handle block allocation. Similarly, by the way, in the case of Pure, Pure gives you, for example, a big pool of all of your drives. I don't really care how they dedupe and compress and replicate those blocks. I don't know if you announced the Nutanix stuff. Anyway, so very much. I want those guys. Okay. but we want those guys to be able to do their magic, and we want to map the application demand on top of that by taking advantage of those things.
But if you consider it as a black box, you could have SLAs on the level of that black box.
Exactly.
Right.
So if you need another volume on top of a Pure pool, we're going to tell you to create another volume, and we can even do that for you. But let you have the platform or the underlying infrastructure vendor take care of the block allocation and the disk allocation for that. And that's actually a very important point, because the other thing that DRS is kind of limited, both storage DRS, is that they're all about moving VMs. Well, what if you don't have enough supply of resources? You can move the VMs around all day long. You don't have enough resources. What we think is really important is to be able to not just find the best place to run each of your applications, but to, in real time, constantly manage the capacity of the supply that services those applications. So this action, for example, of being able to create another volume is as important as finding the best place for the VMs.
So the next logical phase is you're going to start raising purchase orders for additional capacity.
And signing
Actually, it's funny that you say that. So
you're gonna laugh.
So yes, perfect sense. So there's a couple of interesting things. So one of the things that we've done with Cisco UCS, we were able to light up blades and use ESX auto deploy to automatically add them to the cluster, which is as good but faster than a purchase order.
Purchase orders to backfill for that blade when you need a new enclosure.
Exactly,
or a new rack.
We are actually pricing the space, power, and cooling in each UCS chassis. So as you're running out of chassis, we could raise a purchase order for the next chassis.
Give you the bill of materials and get a quote in.
Yep. And I think that your question about the scale-out file system and in general horizontally scaling infrastructure is a really good opportunity for us, because you could pre-stage a couple of those things in your data center, and you could use VMTurbo to automatically light them up, and not only light them up when you need them, but potentially deprovision them when you don't need them and allocate them someplace else. So the reason I'm actually super excited about some of these scale-out infrastructure, not only because they solve a problem about how do you allocate blocks in a system, but because they allow me to automate my supply side capacity decisions and to do that in real time.
Do you find people aren't afraid of that feature? I mean, we're talking on Twitter about even SDRS. People don't even put that in automatic mode. So do you see customers actually embracing like extending a volume and People get scared.
It's challenging to find folks. It's ironic that we talk about giving you control, and we're giving control to people who are control people by nature. And I know I was that person, right? And I would say, like, I always try and think I can outthink the machine. But the good thing is we will make those actions available to you, and at least you can take action on it. More and more folks are embracing the automation, and the automation is also granular. So you can choose, I can automate DRS moves, I can automate, different vertical scaling. Those are all granular capabilities, and it can be done per group. There's a lot of different ways you can narrow that down.
If you're familiar with the capability maturity model, if you've ever heard of that, different levels of maturity, we've got something called an automation maturity model. And really what it does is there are so many things you can automate with VMTurbo. What it tells you is here's where to start. And once you're comfortable with that, here's where to go next. And once you're comfortable with that, here's where to go next. Very few customers will automate everything that we can do right out of the box. Nobody has that kind of constitution, if you will. But the right thing to do is to start with something and then continue to expand it as you get more comfortable with automation, right?
And enabling you to take advantage of this granular automation of the intelligent actions that our software is identifying is allowing you to take that journey. So typically we'll see in our prospects, before they buy our software, it's running in a 30-day POC. They within 15 minutes, you get the first set of actions. They go like, oh, this is cool. They execute a few of them, and after the third day, it's like, let's just do this by itself, right? And let it do it on another cluster, do another cluster, and before they send us the PO, it's fully automated. So I think that the same things will happen, and especially because the thing is, it comes down to scale. Right? If I have 15 VMs, fine, I can do this manually, but these guys have 20, 30, 50,000 VMs. They cannot sit there and choose which action to automate. They have to rely on it to do these things automatically. And if you think about web scale, there is no way that you could, at one point, humanly take all of these actions. Now, we're not forcing anybody to do this, but naturally they are converging to automate
the
more
bonus
and more.
is you can use your credentials and look like you're doing all that work.
But, yes.
If I was up at 2
Or you just
a.m.,
outsource it to some dude in India or whatever, like that one guy
be
from a couple of
plankers,
years ago. Yeah, so. Hey, before we were talking about granularity, before we get too far, I want to ask about the permission model. I'm pretty hot on multi-tenant private clouds right now. It happens to be sort of on my mind. And when somebody provisions, what does a permission model look like? When somebody provisions something, can this thing automatically detect a new application that's been created in vRealize Automation and then put it in somebody's view here, such that
Absolutely,
because that's a failing in, I would say, 99% of all software out there. That it works with VMware and vRealize Automation, but it's not multi-tenant. When somebody creates something, it doesn't automatically or a short time later appear in a view that only they can see. That sort of thing,
Absolutely, and by the way, I think one of the beauties of us creating this marketplace abstraction of your whole data center across multiple clouds, multiple virtual infrastructures, and for the whole stack, the most important advantage is that we actually can apply control across the whole thing. But the other side benefit is that all of the visualization that we do is built on top of this abstraction. So once I introduce a new application, a new container, or a new storage vendor, all the functionality that we had, such as multi-tenancy, will apply to all of those things as well. So what you can do is you could define users or 80 groups of users, and you can define a limited scope for them, where you could say that I only want this group of this user or this group of users to see this subset of the infrastructure. And as we are also discovering all the things that are being deployed in infrastructure, and we're automatically grouping them or tagging them based on whatever criteria you might apply to that group, cool. These things will automatically pop up in their view.
Excellent. Thank you. Both for implementing that and explaining it.
It's curious to see our growth as we've talked, when we saw the first slides, the idea that 10 years ago, virtualization was like, I'm starting to look at it. And, and now it's like, multi-tenant cloud, I'm starting to look at it. As we continue to evolve, it's easier to sell the value of automation and and even better integration. It's no longer the idea of it has to be one whole set of hardware, one whole set of software. Yeah. We can have multiple endpoints.
Well, and that organizations are not one big happy family either. That's the big thing about cloud is that virtualization was a no-brainer as far as it just printed money for people. But clouds and that it's about people problems. It's not about the technology. And people. It's
talking my language. I love this.
Yeah, it's a giant people problem, and everyone freaking hates each other. And the reason there's all this shadow IT, there's a server running under somebody's desk or whatever, is because they want to kill you. And it's like, yeah, and it's because you're not doing stuff and they want all this stuff. And so, a multi-tenant cloud, private cloud is looking like the next sort of evolution for this. Just get them all back, get all of this crap back in a data center where we can control it, wrap our arms around it and our minds around it, but you can still have that level of control that you had with the 7-year-old, 8-year-old server that's not under warranty, that has all your crucial data and all that stuff under somebody's desk. It's a risk management play, really.
Right.
So
yeah, and the control at cloud becomes a tough layer of complexity that most people don't understand. Yeah. That you want to create this little subspace where you can allocate a group of people access to these resources.
Yeah, but let the developers do whatever they want. Let an engineering department, let whoever do whatever they want, like they've been doing in their own little closets under their desks, all that stuff. But you've got more visibility into it. So.
And as an overall admin, you get to see that global view as well. So your scope of view.
Yeah, and that's essential. But like I said, most products out there miss the whole. I want a developer to be able to provision something at 3 a.m. on a Sunday, and then I don't have to do anything. Like a lot of products rely on me going in there and taking their VM and dropping it into some sort of permission group or whatever, and that's crap. And I don't want to be in the loop. That's the whole point of automation is I'm not in the loop anymore. And so.